Oh, great. Today we're doing section 2.2, day 2. Our objective is to write equations of lines. Today we are starting off with slope-intercept form. Once again, if you were in Algebra 1 at some point in your life, you have talked about this before. One way to write an equation for a line is in slope-intercept form, which is y equals mx plus b, that goes in that little box there, where m is the slope and b is the y-intercept. You can graph any equation in slope-intercept form by doing the following. Plotting the y-intercept on the y-axis. Step 1. Step 2. Using slope to plot two additional points, using it as rise over run. The slope, rise over run. Step 3. Connecting the 3 points to form the line. On these, we are going to graph using slope-intercept form. So we first need to state the slope and the y-intercept. So that would be m and b. I know it doesn't say it on the slide, but on the guided notes it says state them and then graph. So those are the directions that we're going to read and follow. Who can tell me the slope or m on number 1? Charles? 2. If you want to write it as 2 over 1, that might be helpful. And what about the y-intercept? Negative 3. Very good. So if it's a minus 3, our y-intercept is negative 3. So let's follow those steps. Step 1, plot the y-intercept on the y-axis. So that means I'm going to negative 3 on the y-axis, and I am putting a point. Then I am going to use my slope, my rise over run. That's why it's helpful to have it as a fraction. If my rise is 2, I'm going up 2. My run is a positive 1, so I go to the right 1. Up 2, right 1, put another point. But our directions for graphing said that we use the slope to plot 2 additional points. So then I can go from that point I just made, up 2 more, right 1 more. If you want to do more than 3 points, you are welcome to do so. But 3 is all we absolutely have to have. Okay, so once we have at least 3 points, we form a straight line connecting them. But remember, we're not just connecting the dots. Just like yesterday, I want a line that goes through your points, but through the whole graph, with the arrows on the ends. Use the edge of your ID or something else that's nice and straight to help you do that. On number 2, we start off identifying our slope and our y-intercept. Somebody that has not spoken to me today, tell me what my slope is. Negative 2/3. Okay, and what about my b or my y-intercept? 5. Okay, the steps. 1, start at the y-intercept, plot it on the y-axis. So I go up to a positive 5 on my y-axis, and I put a point. Then I use my slope. When I've taught this in the past, students have been confused when there's a negative sign out in the front. So my advice to you is to either write the negative in the numerator or in the denominator. It does not belong to both. Give it to one or the other. I like it to be in my numerator personally, Sometimes it works better for the graph if you put it with the denominator. So for me today, I'm going to put it with my numerator. So -2 is my rise. That means I'm going down. Down 2. That 3 is positive, so I go to the right. Down 2, right 3, put a point. Do it again. Down 2, right 3, put a point. Then we connect them using our straight edge. Something like this. Arrows on the ends. Changing equations. Often equations are given in standard form, which we talked about yesterday, but must be changed into slope-intercept form in order to see the slope. To change an equation into slope-intercept form, solve the equation for y. In other words, get y by itself. Okay, on these we are going to change them into slope-intercept form, state the slope, state the y-intercept. Lots to do. So before we did problems where we solved what were called literal equations, which means it had just a bunch of variables in it and you had to get a certain variable by itself and everyone hated them and it was awful. Part of the reason we did that was because we have to be able to manipulate linear equations in a similar way. So we're going to have to leave x as part of it, but we're going to have to get y by itself. Okay? So that's our first step, get y by itself. In order to do that, I am going to subtract 4x from both sides. That leaves me with 3y equals, you can write it as 7 minus 4x. I'm going to write it as negative 4x plus 7. Because I know my goal is slope-intercept form. And in slope-intercept form, the x comes first. Right? Y equals mx plus b. Y is not by itself yet, so I need to go through and divide by 3. Now, you could put one big fraction bar over here, but I'm not going to recommend that on these. I'm going to divide every single term by 3. Just split your fraction up already. Otherwise, you're just going to have to do it on your next step anyway. Okay, so instead of putting one big fraction bar, I'm going to divide the x part and just the constant number part by 3. That gives me y equals negative 4/3 x plus 7/3. If you wanted to leave the x up in the numerator, technically that's not wrong. However, I like to write it next to the fraction instead of in the fraction. I think that makes it easier to identify our slope and our y-intercept. What is the slope? Negative 4/3. So the slope is the m, it's getting multiplied to x. Y equals mx plus b. So my y-intercept is 7/3. Now, another reason why it's nice that we edited the directions on that was that that would not be pleasant to graph. Okay? Not impossible, just not pleasant. Okay, if there are no other questions, we'll do 5. Number 5, we're trying to get y by itself. Okay, so I'm going to have to subtract this whole x term. So subtract 2/3 x from both sides. That leaves me with y over 3 equals negative 2/3 x plus 5/3. Notice that I put the x term in front of the constant term, but I kept the constant kept the constant term positive while the 2/3 stayed negative because I was subtracting it. Y is not by itself yet. What do I need to do? Multiply by 3. So I'm going to multiply every single piece of this by 3. If you want, you could just do like big parentheses around the whole thing. Everything's getting multiplied by 3. On this problem, that's convenient because what's it going to do? It's going to cross out all over the place. So it cancels those 3's, it cancels the denominator here and there. All those denominators now are going to be gone. Every single piece got multiplied by 3. So we have y equals negative 2x plus 5. Now y is by itself, so I can identify my slope, or m, and my y-intercept b. What is my slope? Negative 2. If you want to put negative 2 over 1, that's fine. Go for it. You don't have to. What about b? 5. Questions about examples 4 and 5? Okay. We're ready to just keep on going. Maybe? Ian, are you still with us? It's just really hard for me to tell when you lay your head down like that. Okay. You're taking notes and everything? Oh, good. Okay, more fill-in-the-blank directions. For writing equations, you can write an equation in slope-intercept form if you are given the slope and a point on the line. To write your own equation, write down the slope-intercept form equation. So write down y equals mx plus b. Substitute the slope in for m and the xy ordered pair for x and y. Then, step 3, solve for b. Then you're going to go back and start over and write the equation using the slope, which you should have already known, and the b value that you obtained. Change into standard form if necessary. It's not always going to be necessary. Sometimes the directions will tell you to. If they don't, you don't have to worry about it. So, just another reason why it's nice to read the directions. Okay, so let's use those steps to write an equation in slope-intercept form. So, remember, we're going to be using y equals mx plus b. That was step 1. Just write that down so you know what you're doing. Plug in the things you know.
This is supposed to be on number 6.
Yes, so this is really number 6. We changed the numbering earlier, but I'll do that there. So this will be 6. This one will be 7, because we skipped that graphing one earlier. So it's going to throw off all of our numbers. Okay, step 2 from those steps we just wrote. Substitute the slope in for m.
3.
So 3 goes in for m. What am I going to plug in for y?
5.
5 from my point. 5 for y, and what for x?
-1.
-1. Again, that came from that point they gave me. So I plugged in my m, my y, my x. Now I can solve this equation for b. Please do not accidentally confuse yourself and think that this is a 6. My b's and my 6's look awfully similar. So when you're writing your own stuff, especially, make sure that you know if it's a b or a 6. That is a b. Okay, solving for b means that I need to multiply these together.
So
Wonderful. How am I going to get b all alone?
Add 3 to both sides.
Wonderful. b equals
8.
8. Okay, but I'm not finished yet. Next, we have to write the actual equation using the b value. So now I have to use this along with my slope from the very beginning. At this point, we're done with that point. We just kind of ignore that. So we go back up here and we write y equals, what goes in for m?
3
Still the 3. X
plus 8.
plus b, which is 8. And that is our answer. Okay, I have a lot of students in the past that have gotten all the way to b and then they stop. Okay, you're not done yet if we're asked to write an equation in slope-intercept form. An equation in slope-intercept form has an x and a y in it. So don't go back and plug everything back in. Move on to number 7. Okay. Again, starting with y equals mx plus b, we are going to plug in the slope, the x, and the y. What's going in for y?
4.
4 equals in for slope. Negative 1/2 times
Negative 2.
negative 2 plus b. Beautiful. When we multiply those, we should get a positive 1.
True.
And then to solve it, we get b equals
3.
3. Okay, I wrote a little less work that time, but I'm hoping we're all still okay. If not, let me know. Once we have that b equals 3, we go back to our original form. We plug in m and b only. So y equals
Negative
1/2.
plus 3.
Wonderful. Negative 1/2 x plus 3. We only plugged in m and b to get our final answer. Again, we're always going to go back to that y equals mx plus b on these. We start off by plugging in m, x, and y. What goes in for y?
7.
Equals. What goes in for m?
1 plus 2.
0. In for x is 1 plus b on the end. 0 times 1.
0.
So what does b equal?
7.
All right. We go back up to the original form again. We only plug in m and b.
It's confusing.
Y equals, what goes in for m?
But you even have 0 eggs.
0 times x
Plus 7.
plus 7. Okay, so the question was asked, can you even have 0x? Yes, we can, but that means that we can simplify this more. 0 times anything is just what? 0. And 0 plus 7 is 7. So we could just write this as y equals 7.
That's why I'm
Okay. This is a special case. I believe tomorrow. Yes, tomorrow we'll talk more about why that happens, when that happens. But if this were a question like on a test, I would accept either one of these. Technically, I prefer the bottom one. But I don't think I would fault you if you put a 0x in there. Questions before we go on to 9?
No.
Okay. I'm hoping we're feeling like pros at this now.
Yeah.
What am I plugging in for y?
Negative 2.
In for m.
2/3.
In for x. Okay. Wonderful.
Negative 2 equals 4 plus b.
Alright, so if we take 2 times 6 divided by 3, that's how we get the 4. Or, again, use a nice calculator. It'll help you out. What do we get for b?
Negative 6.
b equals negative 6. To get our final answer, we go back to the original form, but we only plug in m and b. So y equals
2/3 x minus 6.
2/3 x
minus 6.
minus 6 because b was negative. So there are all of our examples for section 2.2, day 2.